Let's look at the mechanism for the nucleophilic substitution reaction. This is the hydrolysis of a haloalkane, converting it into an alcohol. Before we get started with the mechanism, let's just recap what is meant by a nucleophile. I'm hoping you'll remember that a nucleophile is an atom or group of atoms that is attracted to an electron-deficient carbon atom where it donates a pair of electrons to form a new covalent bond. In this example, our nucleophile is our hydroxide ion, so our OH-, where we have a lone pair of electrons on the oxygen atom. Let's then have a look at the haloalkane. I'm hoping that you'll remember that chlorine is an electronegative atom, and therefore it holds a greater share of the electrons in the carbon to chlorine covalent bond, and so we describe it as being delta negative or partially negative. This means that our carbon is delta positive and is electron deficient. This means it is able to accept a nucleophile, attacking it and donating a pair of electrons to it. When the nucleophile attacks the carbon, it is going to approach from the opposite side to our chlorine atom. This will help minimize repulsion. So remember, we show this movement of an electron with a curly arrow. We need to be precise with our curly arrows. So it needs to go from the lone pair of electrons to the atom that it is forming a new covalent bond. This will then cause the carbon to chlorine bond to break via heterolytic fission. And we then form our product, which is our alcohol. And our chloride ion. When you're drawing your organic product, make sure you show the correct connectivity. So the carbon is bonded to the oxygen atom, which is bonded to the hydrogen, not the carbon bonded to the hydrogen, bonded to the oxygen. This is incorrect. Some of you might have noticed that despite the fact we've been looking at drawing these structures in 3D all year, in this example, I've drawn it in 2D. The reason for this is the mechanism is slightly more complicated when we draw it in 3D, and we don't need to worry about that at A level. The mechanism for the hydrolysis of haloalkanes is going to be the same for all haloalkanes, with the exception of fluoroalkanes. You might remember that the carbon to fluorine bond is the strongest bond of all of the carbon halogen bonds, and therefore we're not able to cleave it via nucleophilic substitution.